In this video, we will cover iterators and iterables. It's easy to mix up these two concepts, but as we learn how they relate, you will also be able to learn how to differentiate them. And so let's start with a simple list containing the numbers 1, 2, and 3. One thing that we can do with this list is that we loop through it. So we write for element in nums, and then each element we print. And so we get the numbers 1, 2, 3. If we can loop through an object, or in other words, if we can iterate through an object, then we call that object iterable. So in our case here, the list is an iterable. Now let's have a look what's going on in the background. So we can ask the question, what is required such that an object is iterable? And the only requirement in Python for an object to be iterable is that it can provide an iterator. So when we write this for loop here, internally there will be an iterator created for our list, making it thus iterable. And now what does this iterator do? The iterator does two things. First, it keeps track of a current value. So as the iterator is created, this initial value would be, for our list here, 1, for example. Of course, it could also start at another position, but for the conventional iteration, we do start at 1. And so then the second thing that an iterator has to do is provide us with the next element. So coming from the initial value 1, we also want to get the next value 2. And then again, this will be our new current value that the iterator keeps track of. And then from here, we want again the next value, which would then be 3, such that we have access to all the elements if we call next often enough. Note that the iterator does not have to provide a previous or reset function. So we only need this forward direction that we're also used to when we write these for loops here. Okay, so our list nums is iterable, or it is an iterable, because it can provide us with an iterator. To check if an object can provide an iterator, we can use the dir function, which returns all the attributes and methods of an object. So we can print dir of nums, and then we can see here there's an iter method. And next to the iter we can see 2 underscores on both sides, indicating that this is a dunder method. And so what we can do is that we call this dunder method directly by writing nums dot underscore underscore iter underscore underscore and the brackets. And this gives us then a list iterator object. And we can assign that to a new variable. Let's call that enums. And now while iterators do track the current value that they're pointing to in the object, there's no way of accessing that. But we can always access the next element. And of course, when we now call next on our iterator for the first time, it will not give us 2, but it will start at the beginning. So if we print next on the iterator, then we get 1. And we can call that again. That gives us 2. And then one more time for the last element. Now, what happens if we call next again? So our list is actually finished, but if we call next again, it would jump to a not existing element. And if that happens, then we get the exception stop iteration. And now as a refresher, the relation between functions and dunder methods is that the dunder methods implement what should happen when the according function is called. So to illustrate this, we can print also the attributes and methods of our iterator. And we can see here that there is a dunder method next. And so we can imagine that this function will differ from object to object. So for example, a list iterator might have a different next function compared to a dictionary. And so then when we call this next function on the objects, then it makes sense that these classes, so list and dictionary, implement what exactly happens in their own function or method. So if we wanted to, we could also, instead of putting the function here, call the dunder method with dot underscore underscore next. And again underscore underscore and the brackets, and this would achieve the same thing. And so now this also means we don't have to call this dunder method up here, but we can also simply call the iter function on our list. And if we run that, everything's the same, because this will then internally call the dunder method of the list here and then give us an iterator. One small caveat: if we check the methods and attributes of the iterator again, we see that it does not just have the next method, but also a iter method. And that simply means that we want our iterators also to be iterable. But usually this is not really making anything complicated because this iter method can just return self, so the iterator itself. Okay, so now equipped with the knowledge that for something to be iterable, it needs to provide an iterator, and for something to be an iterator, it needs to have a next and iter function, we can make our own classes iterable. And we can also build our own iterators. So let's define the class myRange. And we want to initialize our range with a start and stop. So we define the init function first by putting self, and then a start parameter and a stop parameter. And then as attributes, we'll define not a self.start, but a self.current. And this will keep track of the current value. And to that we assign a start, and then we'll have a self.stop, to which we assign the stop. And now we want to make this class iterable, but also an iterator itself. So in a sense, an iterator for itself. And to satisfy the iterable requirements, we need the doneIter methods. And so because our class will also be an iterator, we can, in this function, just return the object itself. This will mean that once we iterate, there is no need for an external creation of an iterator, but all the iterator functionality will be implemented in the class itself. Okay, now we have to make our class also an iterator. And for that, we have to implement the next doneIter methods. And in this method, we have to take care of a few things. First, we want to return the current value. You might think that we want to return the next value, and this would also be possible if the current value would be smaller than the start O, would come before the start. So if we want our range to start at 0, then we could say current is 0 minus 1, and then the next would not return the current, but the current plus 1, so the next element, which is then 0. But it's also possible, and maybe a little bit more convenient, to always return the current value, and then in the same step, set the current value to the next value. So that means we can create a new variable called current, which will store the current value. So we call self.current. And then we set the current value to the next value. So our range class will always add 1, similar to how the normal range function in Python is working. So we set the self.current to plus equal 1, and then we return the current value, which now again is not referring to the next value, but to the current value. So if we start at 0, then the first call of next would give us 0 and increment self.current by 1, such that then the next call of next would give us 2. And now one important functionality is missing, because right now we could keep calling this next function forever, since we didn't implement any stopping mechanism. And so now we can decide if we want stop to be inclusive or exclusive, so if it should be part of the range or not. And in the normal range function of Python, it is exclusive, so let's do that also here. And we do that by writing if the self.current is bigger or equal to the stop value, then we want to stop. And we can stop by raising a stop iteration exception. So let's test our class. We will call the constructor with 0 and 5. And then we will try to loop. So we write for elements in myRange, and then we print each element. And just as expected, we get the values 0, 1, 2, 3, 4, not including the 5. Finally, we'll have a look at the Itertools module that is built into Python. And this module provides us with some cool iterators that we can group into 3 categories. First are the infinite iterators. So for example, we have the count iterator, and we can check that out here. So we import from the Itertools the count. And now if we loop through the count, so we write for elements in count, and we pass to that a start. So let's say we start counting at 0, and then we print the elements. Then we'll see this creates an infinite loop that continues counting upwards. And so it's for us to stop this loop either by pressing Ctrl+C or optimally by defining some stopping or goal condition. So we could say if element equals 100, then we break this for loop. So now it will only count until 100. Other iterators in here are cycle and repeat. Cycle allows us to cycle through a collection, and repeat will repeat a certain element. Next up, we have iterators that perform some common preprocessing steps. So for example, this here will accumulate the elements in a collection. So the first element returned is 1, which we can see here. Then the second will not be 2, but 2 plus 1, so 3. And then 1 plus 2 plus 3, which equals 6, and then so on. And then finally, we have here iterators with which we can create permutations and combinations. So for example, let's copy this call here and also import the permutations function. And then we can loop through that. So for elements in this iterator, we print the elements. And then we get all the permutations of these elements here with a length of 2. So we always have 2 elements. We could also do 3. And this would then give us all the sets with a length of 3. So to summarize, if we can loop through something with a for loop, that means it's iterable, and it also means that it can provide us with an iterator, and this iterator also has to be iterable, and it has to keep track of a current value and also implement the next function. And this can be useful if we want to make our own classes iterable, or we want to create our own iterators. And then finally, we can make use of the Itertools module to create some cool iterators.